Okay, ladies and gentlemen, we are going to move into Module 8, Section 5. As we're in Module 8, Section 5, we are going to be addressing the concept of rationalizing the denominator. So as I said, DMA 80, Section 5. If you recall earlier, when we look at simplifying a fraction, if we have the square root of 25, what that means is 5 times 5 is what gives us 25. If you have a pair of 5s, that means the 5 comes out from under the radical. When we are working with radical expressions, it's often useful to remove the radical from the denominator. This is called rationalizing the denominator. The same process applies if we have a radical in the numerator. We would call that rationalizing the numerator. When we rationalize, we will either rationalize a denominator that has one term or that may have two terms. So let me first start with a simple example. If I have 5 over the square root of 3, we have a radical in the denominator. We want to remove that radical from the denominator. In order to do so, we're going to ask ourselves, what can I multiply by to make the 3 come out from under the radical? If I already have one 3, that means I need a second 3. I now have a pair of 3's, and the 3 will then come out from under the denominator. Whatever you multiply by on the bottom, you're going to multiply by the same value on top. You can multiply any fractional expression or rational expression by 1. So the square root of 3 that we had on the bottom, we're going to place also on the top. My new numerator is now 5 square root 3, and that cannot be simplified or reduced any further. Oh, wait a minute. Okay, let's try another. Here we have 2 square root of 9 over the square root of 20y. Now, what I like to do before I begin to rationalize the denominator is I want to see, can any of my radicals as I have them already be simplified? In this case, the square root of 9 is a 3. So technically what I have is 2 times, under the 9 would be a 3 times 3. I have a pair of 3's, so the 3 is going to come out. And what is 2 times 3? That will give us the whole number 6. In the denominator where I have 20y, the square root of 20y, let's review what we learned the other day. If you will go to your calculator, press y equals. We're going to type in the radicand divided by x, and the index of the square root is a 2, so I'm going to raise it to the second power. When we do second table and we look in this column, we look to see if there is a 1. There is not a 1, so that is not a perfect square root. Oh, wait a minute. Something happened with this. How did that happen? Let's clear that out again. 20 divided by x squared. There we go. Second table. Okay. Now this looks better. So as I come down, I cannot find the 1. So I scroll up for the first pair of whole numbers. Here is my first pair of whole numbers. I have a 2 and a 5. That means the 2 comes out from under the radical. The 5 stays underneath. So here I now have, this becomes 2 square root 5, and the y is still under the radical. So that's a 2 square root 5y. What I need to do now is I need to determine to remove the radical from the denominator. I'm going to multiply both top and bottom by the same thing. How many more 5s do I need for the 5 to come out from under the radical? One more. How many more y's do I need? One more. That gives me a pair of 5s. That gives me a pair of y's. So the 5y now comes out. We're going to multiply the exact same thing on the top. So in the numerator, what I now have is a 6 square root 5y over this 5 is a whole number. We're going to multiply times the whole number 2, which gives us 10 and a y. I can still simplify one more step because if I look here, you will notice 6 and 10 are both even numbers. 2 goes into 6 3 times, so that would leave me with 3 square root 5y, and 2 goes into 10 5 times, that becomes 5y. So I'm going to reduce that, divide it by 2. I'm going to divide that by 2. So my simplified answer is going to be 3 square root 5y over 5y. Now, these 5y's can't be reduced. This is under a radical. This one is not under the radical. Okay? Let me write down what I had a moment ago. When you have a square root sign, and you have the radicand underneath, and we want to simplify. When in here would be the index. What you're going to do is you're going to go to y1 and you're going to type in radicand divided by x, and the exponent you're going to use is the same number of the index. Then you use the button second table and you look for 1 in the second column. If you find the 1, you have a perfect cubed root and your answer comes out and there's nothing left under the radical. If you cannot find the 1, you're going to scroll up and you're going to look for the first pair of whole numbers. When you look for that first pair of whole numbers, what is in column 1 is going to come out from under the radical. What you find in column 2 is going to stay under the radical. And what value you had for the index, because you're going to oftentimes have a cube root, fourth root, fifth root, you will still need to put the value for the index there. So I just wanted you to still have a reminder of how to go in and key that in on your calculator. Okay, let's move on to another problem. Let's do one where we have a cubed root. So here we're going to have the cubed root of an m over the cubed root of 27 n to the fourth. So in the numerator, I cannot simplify that any further. In the denominator, we're going to look at the cubed root of 27. So let's go to our calculator, go to y equals, clear. I have 27 divided by x, and I'm going to raise it to the third power. Second table, look in the column, I do find a 1. So this comes out as a perfect cubed root. The answer is going to be 3. So for this particular one in the denominator, this comes out as the whole number 3. If I have n to the fourth power, I have a group of 3 n's. So I'm also going to have an n that comes out, and then under the radical, under the cubed root, I still have a single n. So all I have done so far to begin with is I have simplified the expression that I was given for the problem. Now that I have simplified it, and I'd rather simplify now rather than simplifying in the end. We're rationalizing the denominator. So if I have one n, but I need 3 because my index is a 3, that means I need 2 more n's in order to have 3 n's for the single n to come out. So that means in the numerator, what I'm multiplying by is n to the second power. In my solution in the numerator, I have the letter m and an n squared. M, n squared, there is not 3 of the same. In the denominator, the 3 came out, 1 n came out, and when I add this second n, that now makes that n squared. And at this point, I'm finished. There is no more simplifying that I can do. Most of the problems that you're going to work with are going to have a single value in the denominator, or one term, but there may be an occasion where we have 2 terms. So what I'm going to do is I'm going to come here. Let's see. Let me come into the homework. They didn't have an example of this in the workbook, so let me find one of these on the computer work. Okay, this is a good one. Rationalize the denominator, and we have the square root of 3 minus the square root of 2 over the square root of 3 plus the square root of 2. So we have this, the square root of 3 minus was on the top, minus the square root of 2 over the square root of 3 plus the square root of 2. What we do in this particular problem is we're going to do something that we call multiplying by the conjugate. I'm going to put a parenthesis around here, top and bottom, and when I multiply by the conjugate is the denominator. You're still going to use the square root of 3 and the square root of 2, but what you're going to do is you're going to take the sign where this is a plus, and we're going to change it and do the opposite. You're going to multiply the same thing on both top and bottom. Now this problem is going to give us a good practice of foiling the numerator and foiling the denominator. We learned how to FOIL the other day, so let's look at foiling the numerator. I'm going to do that in red. So we're going to do first outside, inside, last. So as I am foiling here, let me get rid of this for a moment. There we go. So what I'm doing here is the square root of 3 times the square root of 3. There's a pair of 3, so my 3 comes out. When I multiply the outside, I have a 3 and a 2. It will be a minus. 2 times 3 is going to give me the square root of 6. On the inside is also going to be a minus, and the 3 and the 2 is going to give me a square root of 6. Here, negative times negative gives me a positive. I have a pair of 2, so that 2 comes out. Now I'm going to combine like terms. So 3 plus 2 is going to give me 5. And when I combine these two terms, pay close attention because I want you to notice this is a minus 1 square root 6 and another minus 1 square root 6. Negative 1 minus 1 is negative 2 square root 6. So for my whole numerator that I'm going to put on top here is going to be 5 minus 2 square root 6. Now I'm going to move off to the side and I'm going to FOIL the denominator. As I FOIL the denominator, we're here on the bottom. Square root of 3 times square root of 3 pulls out a 3. Outside is going to give me a minus square root 6. My inside is a plus square root 6. And my last, positive and negative, gives me a negative. And 2 and 2 makes the pair of 2's that comes out. The two middle terms are going to cancel. And when I combine 3 minus 2, that leaves me with 1. So in this particular scenario, With the denominator, it's just the number 1. And in order to simplify, well, in this case, it's just an understood 1, so I don't really have to do anything else special to it. Had it been another number, you couldn't reduce unless it would go into both of the whole numbers above. So this particular answer we would write as 5 minus 2 square root 6. So those are our examples of rationalizing the denominator. You do the same process when you rationalize a numerator. It's just you're removing the radical from the top rather than removing the radical from the bottom. Okay? Good job.